Stem cells this, stem cells that. Have you ever wondered what stem cells are, bro? Stem cells. We hear about it all the time in the news. Reversing aging effects, growing human brains in mice, regrowing organs. What does that even mean? But before we do that, we need to learn about what stem cells actually are. Cells can be categorized into two different categories: pluripotent and adult stem cells. The pluripotent ones are basically made from embryos and they're unspecialized. So they don't have a specific function like muscle cells, skin cells, blood cells do. They can become anything they want. You can think about it as a kid. When you grow up, you turn 18 and then you get a career, you get a job. These cells are before that. They're still in high school. They're thinking, what am I going to be when I grow up? That takes us on to the other side of our chart, adult stem cells. These ones are a little bit, they've already decided their fate. The pluripotent ones, they can be anything, which makes them better. You can choose what they want to be. But the adult stem cells, these have an advantage because they don't have to grow up. They're already what they want to be. Well, unlike other muscle and skin cells, these can be renewed over and over again. They can be reused at your leisure. So you might be asking, who even cares? Why do we care about this? Well, these might be the key to getting rid of some diseases like Crohn's disease, cancer, because by doing this, we can find out what they are and how they occur, which then moves us forward to finding out how to get rid of them. We can talk about that a little later, though. Now that we're back, it all started with the mouse. Number one. Most trials start with mice because it's the easiest thing and you don't have to test on humans. This is where this all began. This began in 1991. This is when stem cells first started being treated and they learned about them. Dolly the sheep was a clone of another sheep. It was the first clone that was ever made. This was done with stem cells. Number three, stem cells go human. This happened in 1998. Basically, these were the first human trials that started where human development went to today. The Bush controversy. Basically, what Bush did was he limited funding because a human embryo died. This was in 2001, and he said no new human embryos will be used with research. But he still allowed the old ones to be used, which allowed us to continue research. Not me, but scientists, obviously. Clones, because they are still being researched on. So, a scientist in South Korea, I can't pronounce his name, but he said, I'm gonna still work on clones even though human cloning was still illegal at the time. This led to controversies and he got the stick basically. iPSCs, induced pluripotent stem cells. Now these stem cells were created then in 2007. These are better because they're induced, so they move faster. They can be transmitted faster through the body, and you can get your results faster. That takes us to Obama. Now you might be thinking, what's this guy's last name? Guess what? Nobody knows. But this guy, he brought back funding and he said, we're tired of this. Stem cells are the best, bro. We're gonna keep going. This was 2009. So Bush happened in 2001, 8 years. Then Obama brought it back. That's basically what I gotta say. Treatment. This was the first spinal treatment. This happened in 2010. Now this is really important because this was the first human spine treatment. And once you get the first, you know that can cascade into other things happening. And this will be the case for stem cells too. This will lead us to more things, including human trials. So nowadays, humans are being used in stem cell treatment. They're getting dosages, they're getting all these different things to help them get rid of these diseases. And that will lead us to skepticism, because there's a lot of skepticism within the industry about cloning, about stem cell treatment on humans, all these different things. But first, we got a commercial for you. So AP Bio, what's it even about? Water, trees, cells, organs, natural selection. You ever wonder, why do I look like my mom and not my dad? Why do I look like my dad and not my mom? Genetics, baby. And guess how much it costs? Guess how much it costs to learn all this information? $0. $0. Has anyone told you how we used to be apes? Well, I used to be a monkey. Guess why? Because of evolution. All this for nothing? Why say no? Water? Do you know any of the properties of water? I bet you don't, because you're dumb. But guess what you won't be after you take AP Bio? Dumb. Do you know how the water from the roots of the tree get to the top? You'll learn that in AP Bio. What else? What else do we have to talk about? What else do I have to say to convince you to take AP Bio? Probably nothing, because you're gonna do it. And if you don't, that's all I gotta say. So what was all this fuss about Bush and what he was doing with limiting research, the human embryo dying? So basically, there's a lot of skepticism with cloning, reasonably so, because what might happen if we clone someone without consent, and then bad things happen with the clone? Because what does this all mean? This is all new. This is all futuristic and crazy, and it's all moving very fast. So I think we should have rules and regulations with stem cells, because it is moving fast, and this could all turn bad in a second. And the critics are right. This is scary. All new stuff is scary. But if we don't work on this, maybe we don't save all those lives of people who have cancer or Crohn's or any of these crazy diseases that we don't know enough about. And I think the risk is worth the reward in this case. So it's good. The future. This is what we all care about. This is our lives. This is our children's lives. This is what we will be moving on to. So what is going to happen in the future? You know, you might be thinking that. First off, these stem cells can be used to test new treatments that we might not want to put into people's bodies. You can take out the stem cells, put it in a petri dish, inject the new disease, and then we know whether it's safe to put in humans or not. Now, this can help us in a ton of ways. So, number 2. This one's kind of on the same note, but whatever. So, these diseases can be tested not only to see if it's safe for people, but to see if it works in general. You don't want to be spending millions and millions of dollars administering all these treatments if you could just take a little blood sample and be like, it works or it doesn't work. So, number 3, this one's cool. So, mini organs can be made, and bigger organs too in the future, not right now. But with these big organs, we won't have to have people lose livers or kidneys from other patients or family members saying, I want to give this to a person in need. We can just have it on call. We can be like, yo, give me an organ, give me a liver, and then you have it brought to you, you get the surgery done. That saves a lot of lives. That'll save millions and millions of lives. So this is the really cool one. Let me give you a case scenario. I'm driving my motorcycle over to the bar. I'm a little tipsy, you know. And now I start talking to this cute girl. I'm rizzing her up. Turns out it's your wife. Now you don't like that too much. So you go behind the bar, and you grab a chainsaw, and you go vroom, knock my arm clean off, okay? I got one arm now. What am I doing? What am I supposed to do with one arm? Stem cells. Okay? This is a little in the future. This is futuristic. It'll happen in the future, but right now it's not possible. You could regrow this limb. Now, this isn't possible right now because currently when your arm gets chopped off, scar tissue forms and then it doesn't grow anymore. But there might be inducers that can get rid of that, and then stem cell treatment that will actually regrow your arm. It's very glitchy right now. There's not a lot of scientific evidence that it'll even happen, but I'm pretty sure it will happen. So what do you say? Let's blast off into the future.